In this video, we're going to use our trigonometric ratios, or in other words, SOHCAHTOA, in order to help us solve for the angles in some right-angled triangles. So as you can see here on our screen, we have 3 different right-angled triangles. Each of them were provided with 2 of the side lengths, and we're asked to find an angle. So the angle we're looking for is this one that's indicated with this symbol or this line, and this symbol here is a letter. It's the Greek letter theta. Typically this letter theta is used to represent angles. It would be the same as using like the letter X as a variable. So it's just another letter, okay? In order to use our trig ratios, the first thing we're going to do is label our side lengths based on the angle that we're interested in finding. So first triangle here, we look here, and that side length of 5 is opposite our angle. The 12 is adjacent to our angle. We then look up at our SOHCAHTOA, and we say the TOA is the one that uses the opposite and the adjacent side. So we're going to write a little equation using that. So the tan of some angle theta is equal to the opposite side over the adjacent. We're going to fill in our side lengths. So the opposite is 5, the adjacent is 12. We now have a variable we need to solve for. In order to isolate that variable, in this case theta, we need to get rid of this tangent. And how we do that is tangent or tan -1. We want to do tan -1 inverse tan of this fraction 5 over 12. To type this into our calculators, we can type in shift button and then tangent bracket 5 divided by 12 equals. For those of you that have backwards calculators, you're going to type in 5 divided by 12 equals and then shift and tangent. And if you try it right now, you should be getting an angle of approximately 22.6 degrees. It's not working. Maybe you're typing something in wrong, or double check that you are in degree mode on your calculator. Okay, so then you should see either a DEG or a small d at the top of your screen. Okay, on to our second triangle here. Second triangle, the angle of interest is this one up here at the top right. We're given this side length of 13, happens to be the longest side in our triangle, so this is our hypotenuse. The side here of 4 is right beside our angle. That one's the adjacent side. Note that when we're working with trigonometry, it's rare that our triangles are actually drawn to scale. So yeah, it looks like that side length of 4 seems way too long. It's not drawn to scale. We're just going to trust the numbers. Okay, so again, looking up at SOHCAHTOA, it is the cosine ratio that goes with adjacent and hypotenuse. So we're going to write cos of angle theta is equal to adjacent over hypotenuse, which is equal to 4 over 13. Notice whenever we're using this cosine, the hypotenuse is our denominator, it's the longest side. This fraction is always going to be less than 1 because the denominator is a bigger number. So isolating theta, cos -1 bracket 4 over 13. So we're going to type in that shift and cos bracket 4 divided by 13 and hit equals. On those backwards calculators out there, 4 divided by 13 equals, then shift and cos. Should be getting, again, 72.1 degrees. Again, try it on your calculator. Make sure you're getting the same answer. In our last triangle here, again, we'll label our sides. This side way over here is opposite to our angle, the one at the bottom. The 10 happens to be our hypotenuse, the longest side in our triangle. In this case, our ratio that goes with opposite and hypotenuse, it's our final ratio we haven't used yet or seen an example of. Sine of theta is opposite over hypotenuse, which is equal to 5 over 10. You can reduce that fraction to 1 over 2 if you'd like. You can even divide it out, 0.5. It's up to you. If you, when you divide your numbers though, you get a decimal, you're going to have to keep at least 4 decimal spots. So, isolating theta, theta equals sine negative 1. I'm going to keep this same fraction, 5 over 10. And I'll type that in my calculator again. I'm using a backwards calculator. 5 divided by 10 equals, and then shift sine. I should get an angle of 30 degrees. There you go. 3 examples of how to solve for an angle in a right angle triangle.